want to go over cylinders and quadric surfaces. But first, cylinders. Normally, think of a cylinder like this. One way you can consider it, look at it, is it's really just a circle on the bottom, and then lines that come off of it. So let me draw another one up here. Lines that come off of it, called rulings. Okay, this is how you can think of it being created. All right, so this is a cylinder. So you have your basic shape here. So you have your generating shape here. And then you have lines parallel to it. So lines, lines perpendicular to the shape, parallel to each other. So it doesn't have to be an oval at the top. It can be any shape you want it to be. So if you want, you can look at this one here. This is also a cylinder, but the generating shape is a parabola. So you have the parabola, and then you have lines that come off of it, like this, that are parallel to each other. So these are called rulings. So those are cylinders. Now, what are the equations of them? Well, if you have, for example, this one here, what you notice is that it's essentially a parabola that is whose rulings are parallel to the y-axis. So y is not included in this. They're parallel to the y-axis. So this parabola is z equals x squared. This parabola here, and that is actually the equation of the cylinder formed by that parabola. All right, because this is x-axis, z-axis, and when you look at just x and z together, you have this parabola. Like that. That's this one here. All right, so notice there's no y value. There's no y. So that means that it's going along the y-axis. The rulings are parallel to the y-axis. If you look back up here, this cylinder is x squared plus y squared equals, I don't know what the radius is, so I'll say r squared. So there's no z. So this implies the rulings are parallel to the z-axis. So you can do this all day with different shapes. You could have something like a sine curve that goes along the y-axis, goes down and then up and down like that, and then let's draw that in blue. And now if the rulings are parallel to the x-axis, like this, then we have another sine curve here. That's kind of hard to draw, but anyway, you get the idea. So this one would be z equals sine of y. Okay, so there's no x because it's parallel, the rulings are parallel to the x-axis, just like we wrote before. All right, so that's cylinders. Now let's talk about what are called quadric surfaces. They are kind of like what you saw in algebra or in geometry as well. So in those classes you had x squared plus y squared equals r squared, and this was a circle. Okay, now you're going to have, we talked about this spheres before, x squared plus y squared plus z squared equals r squared, and that was a sphere. Just add the z to that, that's a sphere. But if you look, this is an equation for an ellipse. Ellipses, if you remember from ellipsoid, excuse me, if you remember from pre-cal or maybe even an algebra class. An ellipse has the feature where it's x squared over a squared plus y squared over b squared equals 1. This is where a is not equal to b. Now, if a is equal to b, then this implies then that we have x squared over a squared plus y squared over a squared equals 1. So you get x squared plus y squared equals a squared. Well, that's just a circle. That's a circle of radius a. So if these two numbers aren't the same, a and b are not the same, this one and this one, this one and this one, then you have an ellipse. If a and b are equal, you have a circle. So there you have it. That's ellipses. Now remember what we did with a sphere. We just took our equation for a circle. We added a z component to it, and that became our sphere. Same thing with an ellipse. That we're going to add a z component to this, and that will give us x squared plus y squared. I'm sorry, x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. This is an ellipsoid. So now it depends on which is bigger, a, b, or c, how it goes over the x and y or z axes. So if you look at this ellipsoid here, see how it's further in the y direction. So the term underneath y will be bigger. So here b is going to be greater than a, and b is going to be greater than c. For example, if b is 2 and a and c are both 1, let's look at that. So let's take it down. So if we have x squared over 1 squared plus y squared over 2 squared plus z squared over 1 squared equals 1, then this becomes x squared plus y squared over 4 plus z squared equals 1. Now if you let x and y be, x and z both be equal to 0, then you're going to get y squared equals 4 or y equals plus or minus 2. So in this one, this would be a 2 here. This would be a 2, and then in the back would be negative 2. Now, to show you that it's not going as far in the x and z direction, if you let y and z be 0, you get x squared equals 1. So x equals plus or minus 1. So along the x-axis, it's only going out 1 here. So this is at 1. And the same for z, if you look at the z one. Okay, so there's actually a nice little video of this in the book, in the media. You have an ellipsoid here, and if you look at a, b, and c, a is what's under x. So if you make that bigger, it's going further in the x direction. And then if you make the b bigger, what's underneath y, then it's going to get bigger in the y direction. And the same thing for z. It's going to get bigger in the z direction. Now they can be negative. It's not a problem because you're squaring them anyway. Now, while I'm here, let's look at other objects. Here's a cone. Now, a cone in math is a double-sided cone. We're not talking about ice cream cones here. It's a double cone here. So if you look, it's z squared over c squared equals x squared plus y squared. If it's z equals x squared plus y squared, instead, right, it'll be a bowl. So z equals x squared plus y squared. This is a paraboloid. Okay, so paraboloid. But if it's z squared, like you see here, z squared, it's going to be a cone. All right, so let's play around with the parameters again, see what happens. So if the, underneath x is bigger, it's going to go further in the x direction. If underneath y is bigger, it's going to go further in the y direction. And if it's for z, it's going to go further in the z direction like that. Our next quadric surface is an elliptic paraboloid. This is a paraboloid, like I was saying. See how the z is not squared. So same thing happens. A is bigger, B is bigger, and then Z is bigger. We'll make it like that. Or C is bigger, sorry, C. All right, the next quadric surface is a hyperbolic paraboloid. This is hard to see. It's basically a saddle. Hyperbolic paraboloid, it's a saddle. And so changing these values will move it in the X, the Y, or the Z direction. Okay. Hyperbolic paraboloid. So notice that there are, like, how do you know this? Well, you can memorize the shapes if you want. Basically, what we have here is, if you take it down to very simple terms, z equals x squared minus y squared. You have this is a hyperbola. So when z is like a constant, you have hyperbolas. Hyperbolas like this. And then when you look at x is 0, you have upside down parabolas. So when x is 0, you have z equals negative y squared. So on the x-axis, I mean here where x is 0, where we're looking at just the y and the z, you have upside down parabolas. It's here. It's in the yz plane. It's kind of hard to draw, but in the yz plane, let me draw it. Yeah, this one. You have upside down parabolas. And then when y is 0 in the xz plane, you have z equals x squared. You have parabolas that are pointing up. And that's like right here. See that right there. Okay, so these are called traces of the figure, and we're going to get to that in a second. Hyperboloid of one sheet. This looks like a nuclear tank. So it's x squared plus y squared minus z squared equals 1. So if you cover up one of the variables, like make one of the variables 0, you'll see that, like here, I'm going to make the z 0. Okay, so that's gone now. So let's get rid of this part. We have circles. So when z is 0, there are circles in the xy plane. Okay, so then if you make like x 0, you have hyperbolas. So that's in the yz plane. These are hyperbolas like that. And then whenever you make y 0, you also have hyperbolas, but those are in the xz plane. That's where y is 0. So that'll be like this. Okay. All right. So then that's a hyperbola of one sheet. A hyperbola of two sheets will be separated like this. And this is where, if you notice, two of them are negative this time. So negative x squared minus y squared plus z squared equals 1. We'll do it for you. And so you can alternately make x, y, and z 0, but you can't make them, z can't be 0, because if z is 0, notice that z equals 0 doesn't work for us. It never hits 0 in the z direction, or for that matter, yeah, it will yeah. So if you make z 0, you're going to get, so if this goes away, you're going to get negative numbers equal 1, and that can't happen. So you just study these. Now, one way to study them is through traces, and that is another media thing that you have from this book. Let me take this one away and pull another one in. So once again, it's in the media right over here. So here's a hyperboloid of one sheet. So we're going to look at the traces to trace this out. So these traces are alternately allowing x to be different values. X to be different values. You can turn it even. So now if I let y be different values, so you're looking at y equals a constant. Y equals a constant. See up here, y equals n, y equals a constant. These are planes. Remember, like y equals 2 is a plane that goes through 2 in the y direction. Okay. And so the planes will cut these surfaces and give these curves here on the right. Now if I let z equal n, then you just get circles. All right, so what they're doing is basically alternating x, y, and z to be a value n, and so you get certain objects out of that. So for example, if you look at here, z is like, let's say z is 1, you would go up to the surface. I'll show you here in a second. You go up here and you'd say x squared plus y squared. So equals 2 then. And so this circle is a circle of radius square root of 2. Square root of 2 is 1.5, so that's about right here, yeah, 1.5. So this circle here is this one here. All right, so let's move on to something else. The traces you can do of this hyperbolic paraboloid. So if you look, I'm taking planes and I'm moving them down, and we get different hyperbolas as we go down. These are the traces in the z direction, z horizontal direction. Okay, if we do that for y, it'll look a little different. It's just parabolas. Same thing for x. It's just parabolas that look up and down like that. And same thing for, let's see, they have different surfaces. I don't know what this one is. Surface D. Oh, they're asking what they are. This is a cone. And surface C. They're asking what these are. So that's something different here. All right, so I'll let you play around with these. Looks like a bowl. Elliptic paraboloid. So that's that. And so that's quadric surfaces basically. Now I would highly recommend that you memorize these, okay? Memorize these because they come up over and over and over, all right? At least know the basic ones. Know the ellipsoid, know the cone, elliptic paraboloid. These come up a lot. All right, so that's 12.6, that's quadric surfaces.